Well, welcome everybody. I'm going to be talking about my journey with API calls, and we're going to mainly be talking about calling APIs with Fabric and a little bit with compare it to how it was in Synapse and Azure Data Factory. I'm clicking. Yeah. So my name is Jor Braakman. I work at InSpark. I've been doing T-SQL since 2005 and Python since 2016. I'm 36. I'm married to Joy, who's from Seattle, Washington, and we have two young kids, 2 and 5, two little girls. I have a YouTube channel and I have a LinkedIn. I'm the only Jor Braakman out there, so if you just search for my name, you'll find me. Why this session? I've had to call a lot of APIs, and calling APIs isn't always easy. You can't always not everybody uses the standards. So we're happy with REST, and if somebody has a SOAP API, we can deal with it. And this has been my journey for the last 7 years calling APIs, and hopefully you'll learn what will work for you in Microsoft Fabric. So you might think that juniors have it easy these days with ChatGPT. So I asked a blank ChatGPT, give me a Python function to call a web API with. And ChatGPT does what it does best, produce mediocre code. So it's telling me to pip install requests, and then it gives me this code. So it creates a function for me, and it has some defaults, and then it's going to get that URL with certain parameters and headers and return a JSON to me. Well, it's not that simple, unfortunately. As Atte has finished the session with, we can get rate limited with a 429 error, and we can also get a 403 if the server suddenly is unavailable, or we can get a bad gateway error. There's all sorts of things that can happen, and like the default code that ChatGPT provides here deals with none of it. So, time for the demo. I'm going to show you how you can use a notebook to call APIs in Fabric. And the immediate question you might ask is, why are you using a notebook? Why just not use a pipeline with activities in it or a data flow? Well, they don't always play nice with some APIs. For one customer, I had to implement the extraction of data from an API, and they wanted a different content type. They wanted me to add vnd.retailer.version9 plus JSON. And you simply cannot change this through the REST connector in Data Factory or with the other activity, the lookup, also doesn't accept a different content type. If you try to hack it in through editing the pipeline JSON, it will still not do it. It will always send out a application/JSON. Now, since this was a couple years ago, but in the latest version, this company finally changed their content type to accept a normal application JSON as well. But at the time, I had to do this through a Synapse notebook. And that's where my journey started for software as a service. So
That's
let
the
me
first
get this
question in the chat.
Yeah.
So can you see the chat, or do you want me to read it out?
I'll just open here. Question. As you show in the beginning of your notebook, you start off with import requests. Does this mean that this Python library is available by default in Microsoft Fabric? It sure is, as are all the other libraries that I'm going to import in cells below. Yeah, it's great. Fabric provides a wide environment with tons of packages straight out of the box, and you can start right away. If something is not available, you can install it in the first cell by typing %pip install, and then you can comma separate all the libraries that you want. This will take some time though, as it has to get them from the PyPy library and install them on your cluster. Takes some time. Okay, so pipelines are great because they're low code, because you can basically let a junior do it, and you know, when you are doing Python, you need somebody who knows Python, and not everybody knows Python. Somebody who's handy with just Power BI might be able to pull off a normal data pipeline. So, like Atta was saying, there's some other things as well that can happen. You can have weird tokens, other weird content types. You can have to deal with an XML API out there, or Proto, or some other things. And there's also just, this is what I encountered at one of my clients. So they had an internal API, and the internal API would give me a 200. And then it would put this in the JSON. And yeah, well, I wasn't happy with that. And as Atta said before me, there's a lot of bad APIs out there. So let's continue on with our requests, because we're talking about efficiently calling APIs as well. So I have an API here, and this is just for demo purposes. This is a very simple API where you can get JSON from, and with this API, I'm just calling it 50 times to get a comment ID. And it takes about 3 seconds to get these 50 comments out of it. On average, that's 60 milliseconds per call. And this is with requests.get. Now, let's use a session object, because what ChatGPT provided for us is not very efficient. A session object holds the connection. So while a request opens up the connection with the server and then closes it again, a session object can hold it open, so there's less HTTP traffic going there. So let me just demo that. And for the 50 responses, it now takes 1 second. On average, 20 milliseconds. That's like a 300% improvement. So as your journey goes on with calling APIs, you might want to handle different status codes. So let me run this real quick. And what we can do here is we can append the JSON to our list here only on static codes that are valid. So that's 200, 201, and 202. And then if we are requesting too much, we can sleep for a second. But you can also do something fancy like response.headers retry after if the 429 response has a retry after key in the header. Now, sometimes this will not be retry after in seconds. Sometimes it will say blocked until and then a datetime. Or in the case of Microsoft Graph, it will have a very long key name. But by using Postman or printing your response JSON, you can see the headers. And of course, if it's not 429, please use the raise for status function. That should be on the response object, by the way. To handle any other errors. So you can also do something like raise base exception. Whoop. But please don't. Just use the built-in function method in requests. So what's actually happening here for 429 after you call sleep? Well, nothing really happens, and then the function does not get your comment ID. So what you would need to do, what you might do as a junior, just copy paste this in here again, and then, but what if this gets a 429 as well? Well, it's better to create this as a function and then call the function. So that's what I did here. I made a requester function, and the requester function gets the session and the ID that it needs to get, and then on a successful response it returns to JSON, and otherwise it returns a new call to the same function. And this is called recursion, and there's a limit in Python and in PySpark for how many times it will do that, and the standard is, I think, 1,000. And I hope you don't have a 1,000 recursive calls, because the person you're asking will not be happy with you. So how can we still improve our calling of APIs? We can do async programming. And what does that? So up until now we've been doing synchronous calls, and with asynchronous we can send out 2 requests to the server, and the server will send these back. And this uses an event loop. So we have to make tasks. Those are, for example, the comment IDs, and then the event loop will just loop, and it will call the server. And this is great for intensive file input-output or network input-output. And when the server replies, it goes back to the event loop, and I will say that the task is finished. So there's 2 ways to do that with these libraries. We have AO HTTP and async.io, but the functions are a little more complicated. So also using a library called Tenacity, and Tenacity provides decorators and functions to handle the retries of your function. So I decorate this function with the retry decorator, and then it will wait 1 second, and it will stop after 3 attempts. I have a very simple async function here to just get the URL and return that, and the await and the async keywords here signal that this is an asynchronous function, and yeah, that it needs to wait here, and it can return to the event loop. This is not a session on async.io. There's plenty of good YouTube videos up there. So let's see what happens when we call async.io in a Fabric notebook. You get an error. And the error is here on line 15. Loop dot run until complete. This actually starts the loop. And what it says here, the event loop is already running. How can that be? Well, the thing is, this whole notebook is running in asynchronous mode. So Microsoft is already sort of doing it for you to provide a seamless experience in this notebook. It's not exactly Python code, it's PySpark in a web session. So there's this magical library called Nest Async.io, and it's already installed on your standard Fabric cluster, and you run Nest Async.io apply, and then, as if magic, it works. And the 50 responses now only take 360 milliseconds, an average of 7 milliseconds per call. So this has been a great improvement over the last iteration with the session object. And it is a lot more complicated to read and understand, but it is a lot quicker. And since we pay for vCores per second, this is a very efficient solution for you. Unfortunately, it's now code review time, and my chief data scientist is looking at my code, and he's telling me in Synapse Workspace, you are not using the executors. This is running on your driver node. So immediately it gets more complicated if you want to use the whole cluster. I've been running this Python notebook here, or I should say PySpark. This PySpark notebook, and we've been doing this here for 12 minutes. Let's see, which one was it? And I'm at 0% efficiency. How could that be? Well, my chief data scientist is right. This is not Python per se. We do have Python notebooks nowadays, but we are running in PySpark mode here. And on Synapse as well, there is a driver node, and there are executors. And the driver node is just managing the executors. So how would I run these requests not solely on my driver node, but on all my executors? Well, you have to do that through a user-defined function. And in a data frame, you have to call that user-defined function. So we have this function here from before. Let's just call the UDF function in PySpark functions and do this, I guess. So I'm creating a data frame here with the numbers 1 through 50, because it's not inclusive of the end. And unfortunately, this fails. Cannot pickle thread local object. What is going on? Very long error. Could not serialize object. Cannot pickle thread local object. So what's happening? It doesn't like the asynchronous. You can't send certain objects to your executors from your driver node. An example is the session object can't be sent to your executor nodes. So can I just sneakily apply nest-async.io in the function and then call it? No, it's the same error, and it all has to do with how the Spark cluster works, and the Spark cluster is not made for asynchronous programming. As far as I've Googled and looked through Stack Overflow, people are saying, "Don't do it. You'll regret it later." So I didn't go on with asynchronous programming on the executors. So what's the next step? Why was I doing this in the first place? I had a client who wanted to do 14 million API calls very quickly, and they already had some infrastructure, and this was chosen, and I got picked to do it. So what I've done is I've just used the request.get method here, and I've created a Spark user-defined function out of it. And now you can see that a Spark job is running. And I get my result here in a new column called result. And I can explode or select, etc. from this column. So the nice thing about this is that I called the API and I have the response in a data frame already. And I can easily write that to Parquet. Why repartition? So after this whole portion has run, so this is what is actually running the function, the user-defined function. I use repartition.200. And that is because Spark is not really made to do API calls. It's made to handle huge Parquet files and do data analysis on it, data engineering, the transformation part. And the repartition 200 is basically a huge number, telling that each task is we're basically faking that each task is a very hard task to do. So if you look back up at the image here, we want a lot of tasks because each task is I/O intensive. And the more tasks I have, the quicker this all will be done. Otherwise, I will have one task run by one core instead of having 200 tasks being done by 8 cores. So let's go back down. And the duration here was somewhat longer, and the because we're using the request function, on average it's slower. But the nice thing about this is that I can add more executors. I can basically add as many executors to my Spark cluster as Microsoft allows me to have vCores in my resource group. Now, are there other ways this can be done more efficient? Probably with an Azure function or the equivalent in Fabric, which I think were announced at FabCon, the Fabric functions. But they are less memory intensive and a little cheaper. So, what is the takeaway? I also have a pipeline. So if you're wondering what does this look like in a pipeline, basically I have a source, which is this, and then I put in the items here. So I have this sample set's a little larger. I have all numbers through 500, and then it's going to call this web API and put it in the landing zone. Now I can run this, and you have some queuing time. And it will try to do a bunch in parallel. And as I've said at the beginning, this is low code. You can click it together. A junior could make this. But if we look here, it is taking some time. Where my Python, my worst Python code took like 3 seconds, this is still not done after almost a minute. Now there are high concurrency pipelines in preview, and they are quicker, but they still don't compare to what a notebook can do. So while I let this run, I'll just go down here and I'll go over the pros and cons. So nowadays we can have Python here. If you logged into Fabric this morning or yesterday, you got a nice pop-up that this is available. And Python is great. It's efficient. I also have here the async.io version in pure Python. So this does not run on a Spark cluster, and this runs on Python 3.11. And let me just quickly boot this up. So as you can see, this runs on 2 vCores with 16 gigs of RAM, which is plenty to do API calls. You'd have to get really big JSONs before 16 gig is going to be an issue. And for the asynchronous programming that we're doing, 2 vCores is also fine. Now, it takes a little while to boot up, but all these libraries are just available in the Python kernel as well. So while we're waiting for this session, are there any questions so far?
There are no questions in the chat so far.
Okay. So while we wait for this Python kernel to boot up, I'm going to show you that the other notebook now has its efficiency increased, because over the 24 minutes of it being up, I've actually used the executor nodes, and that's going to up the efficiency. Not by a lot, of course. So now it actually booted up. And it's importing all these libraries. And bam, done. So reading the libraries, importing those, I don't really think it took 23 seconds. But running the Python notebook was blazingly fast. It took less than a second to get all the responses, and then less than a second to put all of them in my lakehouse. Meanwhile, I think this thing is still in progress. So that's why I don't like the pipeline very much. What is the downside of async IO? You have a lot of JSON files, and if you want to write these, if you want to read all these JSON files into your Spark cluster or in Databricks, Spark doesn't like a lot of small files. So the upside of the Spark UDF is that you immediately have your data in the data frame, and you can start to use from JSON and explode, or with column and all the other beautiful functions that we have in Spark. The downside, of course, is that it's not asynchronous. So if you just want to have lots of small JSON files, I do recommend using just pure Python with async IO for low cost and low time. So what about money? So I've gotten access to the Fabric Capacity Matrix app, and there you can see how long it takes for the notebooks and the pipeline to run, and what that translates to in capacity units per second. So the difference is really low, but you can see that so the first one is also a Spark cluster, but you can see that using async IO has the least capacity units, and using a pipeline is a really bad idea. So you have to divide these numbers by 3,600, because these are in seconds. And if you divide this by 3,600, that's the capacity units it takes. So for example, if I were to run this for an entire hour, 135 divided by 3,600, it will take 0.0375 capacity units. So with an F2, this is fine. If, however, I'm using the pipelines, that's 12 capacity units. So you'd need at least you need to burst with an F2, or have at least an F16 if you want to do something like this constantly. So what about my client? Well, my client ended up using 76 executors. Each executor had 8 cores, so we could do 608 calls simultaneously. Each call to their lovely API took about 5 seconds, and the whole thing ran for about an hour and 20 minutes. And that would have been a lot harder to scale with just using async I/O, because there was some recursion and other fun things going on with that client and the API calls as well. Yeah, so that's basically it. So, oh, well, if there's any questions, please ask them now, and give me feedback.
Link for feedback is also in the chat.
This is what you get when Abi is in the chat. Weird gifs.
Yeah.
So I'm sorry, I cannot be held responsible for that. It's just it's an impulse. That's all.
Well, you know,
Yeah.
as
Keep your
IT
excuses to
people,
the jury.
as IT people, we do love to go for maximum power, of course.
No, that was a really good session. Thank you. That's we're hitting some performance issues with notebooks. It might be because we're trying to run them at the F2 level, but yeah, some really good tips there that hoping to pass on to my colleagues.
Also, one more thing then about APIs. So some APIs, I had it easy with the numbers, right? I could just put in a number from 1 through 50